The idea behind inheritance is that it is a way to reuse code. A lot of design that we do in software development is for the sake of not duplicating our code. So let's say we have several classes with functionality that is common between them, but they're also different enough to need their own unique functions. We could move those shared functions and variables into a single class, the parent class, and these classes now inherit the shared functionality from the parent. Now these classes are child classes, and their unique functionality is seen as a specialization on top of the shared functionality that they all have. For example, let's say that we're designing a user interface. What kind of objects would we need? Well, for some of these, they might have text in common, or they might have some functionality that runs when they're clicked. Some of these might contain other classes. For example, a list might contain an array of labels. And all of these would need functionality that would draw them to the screen. Sometimes you'll see a generic user interface object called a widget. A widget family might look something like this, a series of parents and children through inheritance. Widget would be the great-grandparent that every other user interface object would eventually be derived from. Then you could continue expanding by having classes contain other classes. So for example, button might contain a label, and an image button might contain an image and a button. So because a button contains a label, an image really is derived from images, buttons, and labels. To use inheritance, first we need to create a base class, which is just a normal class. When using inheritance, any member variables that you want the child classes to have access to should be set as protected instead of private. More on this later. Then, to have another class inherit it, you declare the class and put public parent class name afterwards. So now we have a cat class that inherits from animal class. Our cat class will have the functionality inherited from the parent, such as the setName function. It'll have functionality that it is overriding from its parent, so the speak function, and it is adding its own unique functionality, such as the claw function. Even though we do not see void setName within the class declaration for cat, it is still included in there because it is inherited from the parent. Now we can declare classes of either type and utilize its shared functionality in the same way. Only the child can use the functions that were uniquely declared within the child class, though. Okay, so what is this protected label? We haven't used the protected keyword yet because we haven't been using inheritance. We're only using public and private for our normal classes. If you set a member variable or function to private, then any child classes cannot access those private members. However, if you set a member variable or function to protected, it is still treated like a private member, so nothing outside of the class can access it, but when you make a child class that inherits, it will also have access to the protected members. So, protected is accessible to a class and its descendants, but private is only available to that one class. There might be times when you do not want functionality to be shared with the child classes, so that's when using private would be appropriate. So for example, here we have two document classes. One saves plain text, and the other saves a web document. Therefore, they both have private functions for write text file and write HTML file because they're not shared at all. Instead, they have an output function that they both share, and that output function would call the appropriate write function. To the user or other programmers, both the document and web document classes have the same interface. They both have the output function, but behind the scenes, they work differently. We've had some examples of overriding or redefining our member functions, such as output from before. This is when our child class redeclares a function that the parent class has. The redeclaration has the same return type, name, and parameter list, so this isn't the same as function overloading. The function is called in the same way, but will go to the special child version instead of the parent version. Even if we redeclare a function, we can still call the parent's version. We might do this if the new function expands on top of the old functionality, but we don't want to duplicate the old code. So, instead, we call the parent version of the setup function here in order to use the same functionality to initialize name and location, and then we add additional initialization on top of that. To call the parent's version of the function from within the overwritten or redefined function, we use the parent class name, followed by the scope resolution operator, the 2 colons, and then the function name with any of the arguments that are needed. We can also overload parent functions. Remember that overloading is using the same function name, but using a different parameter list. So here, we have 2 versions of setup, it's overloaded, and we can still call the parent setup function, though for the setup with 2 parameters, this is an overloaded function and not a redefined function. Similar to calling the base class's functions, we can also call the base class's constructor. However, to call a parent constructor, we must do so through an initializer list. An initializer list is another way to initialize member variables in a class, rather than manually setting everything within the constructor's body. Here, these 2 versions initialize the same variables, but they do it in different ways. The top is just the standard way we have been doing, and the bottom is using an initializer list to set them up. So, in order to call a parent constructor, we need to do so with an initializer list, just like the following. Then we can use the constructors as normal, and they'll automatically call the parent. Notice that when the parent constructor is used, it'll be called first, before the student constructor. You might have noticed that we use the public keyword when we are inheriting from another class, but what happens if we use the protected or private keyword? For the most part, you'll be using public inheritance. So with private inheritance, any public or protected members of the parent class now become private members of the child class. With protected, any public or protected members of the parent class now become protected members of the child class. These are used for more advanced designs, so don't worry about it. Classes can also inherit from multiple parent classes. So let's say we have a button class and an image class. We could use the functionality and variables from both classes to make an image button class by inheriting from both. Any protected and public members from both classes now become protected or public members of the child class, merging the 2 parents. Here's some sample code with a button and a label. Now the child class will have any non-private members of both its parents. Voila! But inheriting from too many parents can cause internal code to become messy, rather than concise and compartmentalized. So this leads us to another point, is-a versus has-a design. Utilizing inheritance is usually considered an is-a relationship. This means that if text button inherits from label and button, what we're saying is text button is a label and text button is a button. There's another design style that is considered has a relationship, composition. Utilizing composition is essentially making one class a member of another class rather than its parent or child. So here we have text button. We can either inherit button and label, or we can make button and label members of that class. By making button and label members of the text button class, instead of parents of it, we have nicely compartmentalized the button functionality and the label functionality within the m_button and m_label variables. We are adding another layer to the object's design. There are arguments to be made for designing your objects in either way, so ultimately it is up to you. Read other people's opinions, consider them, and figure out what works for your program's design. Okay, that was a lot to cover. You don't have to be a master of all of these topics right now. We're mostly going to focus on vanilla inheritance, but it is good to know what is possible so if you encounter it later, you can do more research. Let's work on an example of using inheritance. Remember that there is also sample code for each of these topics in the course repository. For this program, I've already written a web page class, and it basically will open up a OFStream object. It will then output your basic HTML stuff to the beginning and the end, and in between we can add elements to it. So these have already been added. It's an add element function, so we could pass in a link, a button, or a paragraph, and I'm just going to create the classes for these. So each of these are going to output something different. So a link will look like this, input button will look like this, and a paragraph will look like this. They will all have an ID in common, but a link will have a URL and some text, a button will have a value, and the paragraph will just have some internal text here. So at the moment we don't have any widgets, so let me move web page over here for reference. And in our header file we'll say if not defined widget. We're going to define widget, and I'm probably just going to declare all of the different widget classes in this one file, though usually it's a better idea to make different files for each one. But since these are not going to be a very big set of classes, this is going to be okay. So we'll have a base function, class widget, and at the very basic stuff, we aren't going to make that private, we're going to make it protected. And we'll store an ID, because again, all of these will have some sort of ID. And say string get output, but we're not really going to return anything for just a simple widget because we don't have a type for it. We're going to say set ID, const string reference ID, and we'll set the ID member to the passed in value. So we'll want to override get output for each different type of element, but we'll keep reusing set ID. So first let's do class paragraph, and it is a public widget type, and we'll want to overwrite our get output. So I'll move that down here. But then we'll also have a special text field. So mText void set text. Okay, so for a paragraph, we're going to return just a simple paragraph. In HTML it would look something like this, but we're also going to have the ID. So we can into the string and append the ID. And then within here, we'll append the text. So mText. So now we have a working paragraph. All we have to do is say get output, and we'll return the output after this all has been set. We can also create a button, class button. And I'm making these private because, one, I'm not going to inherit anything else from these, and they're special to these specific types. So a paragraph has text, a button has text as well, but I'm calling it value here. So they have their own set of attributes. We'll have get output and set value. And for our button, it'll look more like input type is button, ID is something, value is something else. So we'll pass in the value. Move that over, pass in the ID, and then that's that. Okay, finally we'll do a link, and a link will have a little bit more going on. We can make it inherit from paragraph, because a link will have some text, kind of like paragraph, but then it'll also have a URL. So let's say public, and this is a type text, or paragraph, sorry. Paragraph, public, private. Now up here, I'm going to make this protected so it can inherit this text object. And then it will also have the link. So we'll still have to override the get output because it's going to look different. But we'll also need a set link function. And then it will inherit set text from here. So our link will look like a href, we'll have the URL, ID, and then text goes on the inside. So okay. So here we're including widget, and we have ability to add links, buttons, and paragraphs. In the future, once we get into polymorphism, we can treat these all as just the base widget object. Since these all have a get output function, they really have not a whole lot of different outside usage. When we're writing to the file, they're all going to use get output, so there's a way we could program this to be a little more generic and just call them all widgets and get output, and then it'll go to the special function based on what it is. But we're not to that point yet, so here, let me build, we get that. We can create a link object, we can set its ID, we can set the link, and I'm not sure if I need to include widget up here. I shouldn't have to because it's included right here. Let me make sure this builds. Widget. Set link. Okay, and we can say link.setText and go to ASDF, build. So we could run this, and it pops up this window. It's not doing anything, it's only outputting some text. So then, let me open this in Chrome. I'm not sure if that was the right thing. Oh, right, we didn't call my page.addElement. We'll pass in the link. Okay, so now it looks like this. There's the go to ASDF button, though the link is incorrect, but we want to pass it in like this. Now it'll actually go to asdf.com. Okay, then we can create a button. Button.setValue. And we can create a simple paragraph. Okay, we refresh this, and we have that. So if we didn't want these on the same lines, we could have a blank paragraph up here. We don't need to set an ID or anything. Do that, refresh. Now we just have this empty one here. So that's how we can kind of reuse the same functionality with certain classes, and then also specialize them. So they all have ID in common, paragraph has text, and then link has text as well, so we just inherit from paragraph directly. So widget is essentially the grandparent of link, paragraph is the parent of link, button is the child of widget, and so on.